And welcome to Desk of Lady Ada.
Hey everybody, we've been doing some video tests today, so thanks for hanging out with us. It's me, Lady Ada. With me is Mr. Lady Ada.
Hello.
So camera control. I made him that box with the buttons now, so you can make me appear and disappear with the touch. Like, watch this. No, don't press that button!
I'm going to make a little one
Don't.
more. You know what's better than one Lady Ada?
What?
Two.
Wah! Clone a button. So you're just pressing the button on the little Python board thing that we made. So that's cool. And then adds this thing. Okay, what's the third button do? Nothing? Destroy Facebook? Okay. So I thought I'd just show off some samples that I got. We talk about these samples. So I've been doing a lot of actually like DSP learning stuff in the last couple of weeks, mostly because I wanted to get this PDM microphone all going very nicely on Circuit Playground. But then I also was interested in interpolation because we put out that thermal camera and I wanted to port some interpolation code to C++. But I wanted to show off some samples for these little Linux modules. So you can go to the computer and I can show you why. So you wrote this article about the Industrial 101, which is the like this module here. And you're asking me about this because like this is basically like an ATmega chip, and then there's this module, and we were trying to figure out what's in this module. Is this open source? And so far it isn't. And you're like, Lady Ada, what is this module?
Yeah, well the thing is, I was talking to Bunny and other open source hardware pioneers and experts like you, and generally speaking, if you put the Arduino logo or any logo on the tin and the logo on the board, the expectation in the community is this is open source because the board says open source, the product page says open source. It says with these files you can build one of these, but Bunny can't, you can't, no one can. So we were trying to figure out, one, will this new Arduino, Arduino.org, will they release the files? And if you scroll down on the page, I documented this. There's all the things that they say.
And this is it, yeah, because I installed OrCAD, which is like a super joyous thing. Don't install OrCAD unless you have to. And what we found is the schematic just said like there's this module. And it's just like a black box. Like there's no information about what's in here.
The owner of the file, it's not Arduino, it says Dog Hunter. So there isn't any open source license or sharing license. And the OrCAD file is just the same thing in the PDF. It's basically a not usable drawing of an incomplete thing. So we emailed Arduino.org. They didn't get back to us. I think Bunny did and a few other people did. And they said, oh, email these other people. There's multiple Arduinos still in some way. So anyways, they didn't respond back. They're not going to respond. Yeah. And it says, it says click here for eagles and zip. It's not.
Yeah, there's no files.
So anyways, so that made us think.
So yeah, so I was thinking like, what's actually in here? Because I've never really used the Young. Like I tried it out once, and then the Raspberry Pi came out, and I was kind of like, well, if I'm going to use the Linux computer, I'll use a single board computer. But inside is this Atheros AR9331, which is actually a Qualcomm chip, and yeah, it's a Wi-Fi system on a chip, and it runs at 400 megahertz, and it's got 802.11 built-in radio. It's got RAM, and then I guess you can connect external RAM, and you can control external flash. It's got USB host and device, Ethernet ports, GPIO, and a bunch of other things. And basically, I guess there's a data sheet, but I don't think that there's like a release document. And there's also like this Dragino, which is kind of like this AR9331.
Well, the problem is everyone's
there's no information.
Everyone's coming out of the woodwork who used to work with Dog Hunter or Lenino or whatever this version of Arduino is, and they're telling me lots of things that I don't know if it's true. So apparently there's reasons why maybe this isn't really open source, and they're saying, but I'm not until I can verify it. I'm not comfortable writing about it. So, anyways, it's kind of.
But that internal is like, and then there's like the reference design. Actually, it's funny. I googled it. I did find a reference design.
There's a leak.
It's NDA.
There's a leaked like data sheet.
Yeah, there's like all these leaked documents. If you look for like schematic, I don't know, I'll see if it shows up.
Yeah.
Just because it's like the internet. And, you search for things and like things appear. You can see like these are some modules. So like this is kind of what's in that. So if you can even see like, okay, there's this main chip that does like the Wi-Fi. There's this WinBond flash chip, and then there's the RAM chip also from WinBond, and then you can see like there's this I guess like a bell on here. It looks like it's a balanced output, and then they unbalance it, and then this is like basically this schematic, but that's like not released, so it's like not super useful for the industrial. But we were thinking about it, and I was like, well, I was actually like, well, let's like get an AR9331 module. Like maybe we can just, you know, if this is an open source, maybe people can make their own. Just by getting an AR9331. Actually, you know, I went looking, shopping around, and like, you know, finding stuff on like, you know, AliExpress and Taobao just to see like what is out there. And it turns out the AR931 is actually kind of expensive. Like getting a module already done, like you know, a module like that image with like the flash and the RAM, it was like $13 or something, $14. It was like pretty expensive, which explains why the Yun is a little pricey. And it would be great if I could just get like the, you know, the Raspberry Pi Zero chip, right? Because it's clearly much less expensive for them to be able to manufacture it for around $5. But that's not really available. So then I went looking around, and it actually turns out that the chipset that people tend to use is this MediaTek chipset, which is basically like MediaTek is kind of. I like MediaTek because they pretty much look at what's on the market, and like especially from Qualcomm, and then they just make something like half the price. So. You can get like, you know, an Atheros AR9331 module, and like I think there's a couple companies that make them, like, you know, like if you look on Alibaba or something, like you can tell that there's a bunch of modules that you can buy, and they're like, you know, about $11 or so, maybe $20 or something. But then when I looked around, I was like, oh, you know, these MediaTek modules are cheaper, so I got a whole bunch of samples, so I thought I could just show these off. I just got them today.
Yeah. And so, can you go back to the article I wrote? It's on the Arduino
this
blog.
one.
Yeah. So the other thing, you scroll down a little bit. The other thing is, see these other logos?
Yeah.
It says powered by Lenino and developed with Dog Hunter. So the current CEO of Arduino also owns those companies. So just aesthetically, just by the way, this is super weird for any Arduino board to have a person who owns a majority of Arduino and then owns these other two companies. And Dog Hunter is not known to be open source.
Nothing's open source.
Arduino Day,
yeah,
it was proclaimed that Arduino is going to be all open source. On Evil Mad Scientist blog, Lenore and Wendell posted up in there and say, hey, like, what's up with the files? And Massimo said, oh, I've emailed my colleagues at Arduino.org, and don't worry. Well, it's been about a month, I think, almost. So, yeah. I don't know. I mean, like, there's only one, besides dancing, there's only one thing we can do. And I think that's to come up with open source alternatives to something that's called open source that's no longer open source or never was going to be open source.
The other thing about MediaTek is, you know, they have the, they're doing the project with the Linkit. So they released actually a lot of files because they're doing stuff with Seed, like the Linkit kit. And so I actually thought like it could be kind of neat, you know, like look at these modules, I can like maybe make a feather. So the first one I got is this HLK RM08S, and this one, let me get people so you can see it. So he's got the MediaTek MT7688KN, and this is a really adorable little module. So this is a full Linux computer, and you can see they kind of print out, you know, this is I2C, and this is the antenna, and I2S, SPI, UART, and then LAN. Although these LAN chips you can also use as like GPIO, like they're Ethernet, and these chips are kind of designed to be like little pocket routers. You basically, you know, it has 4 Ethernet ports, a Wi-Fi antenna, and a power plug. So it's like very minimal. So this is the low cost one, and this is only a couple bucks. Maybe it's $4 per module, which is like incredibly inexpensive. Yeah, it's got USB power function, and it's got the MediaTek 7866 chip. And you can tell there's like only like a bunch of capacitors, inductor here, crystal. And then this SPI flash, and the SPI flash is a 25L16. So this is 2 megabytes of flash. It's very small. I mean, this is like, it runs one thing, which is like Wi-Fi Ethernet routing program. It's very, very minimal. It does run a Linux kernel, but like when it boots, it's like, I don't even know if you get a shell. I think it's just like, hey, I'm running this like ultra miniaturized OpenWRT. And then there's, of course, an antenna connector here. So I thought you can like look up the MediaTek MT76 7688KN. So I actually couldn't find a ton of info on the KN version other than, I think here, yeah, here in the MediaTek page. Okay, so it's got 5-port Ethernet. It's got 8 megabytes of RAM built in. So there's no like flash, like there's no RAM chip, like you usually see a big chunky RAM chip that's actually built in. But it's really, really cheap. So it's kind of like, it has like PCIe, it's like, it's, you know, it's, looks like it was recently released, 2014 or so. It runs at 580 megahertz, so it's the same speed as the Atheros chip. But the trade-off of getting something like this small, I mean, this is like super teeny, is it's got only 8 megabytes of RAM and 2 megabytes of flash. Now, what's interesting is that I've noticed that, I haven't done a lot of OpenWRT, but it's interesting that there's more RAM than storage. And I think what happens is that like the kernel is compressed, and you have like a compressed file system on the SPI flash, and then it's decompressed into RAM. I mean, I'm guessing, but that's kind of what I would do. And then instead of running off a flash, which is kind of, even SPI flash, it's kind of slow. Like, I mean, maybe if it's like a quad SPI, it's not too bad, but it's a little slow. If it's in RAM, it's like you get to basically do all you want with a file system, and then you don't have to worry about file system corruption either, because like, you know, you only write when you absolutely have to write, and honestly, you don't even do that much writing. You must mostly just read from the SPI and just do it in RAM, and like every time you boot, you get a fully fresh file system because like you don't keep anything on the file system. So it's, the file system is more like ROM than RAM. You write it, you know, to put the file system on the kernel on, but then you run from RAM. So this is, okay, so can you do the overhead again? This is the HLK RM08S, so yeah, super small. I just like took out like an ESP32 feather to compare. It's actually about the size of the ESP32 module, but like, you know, it's running Linux on it at 500 megahertz, which is kind of cool. And like, I think you could probably run like some very basic, I mean, you'd have to probably write it in C code and it'd be like low level, but you could write programs in Linux on this and it would just do like, you know, a Wi-Fi radio or something. Because yeah, it's meant for like very small wireless hubs. Anyways, this is a cute one. And then I got a nicer one. So this is the upgrade. This one's like super fancy. This is from Highlink. And this one has a metal can, and it's even got FCC and C certifications. You can see the ID number, 2AD over here. It's got an LED and antenna. So I actually really like this one. The only sad news is it's just too big to be a feather. It's like a half. It's like 1 or 2 millimeters. It's like 1/10 of an inch too big or something. So you just, or 50/100th of an inch too big. So it's a little sad. It is kind of a big module, but it's got this tin. But what it could be good for is, you know, if we wanted to make something that was larger than a feather, like this would be fine. Like if something that was Arduino shaped or like a Metro or something, this could be nice. And then you've got, you know, all the things on the bottom. Like LED and function and LAN. Keep going. USB and SPI, and it's got a couple of UARTs. But the basic difference in this is that it's running the MTK 7688A. So if we look up that on the computer, can you go to the copy? So this one is more recent. Looks like it just came out like only like about a year and a half ago. And it's got external RAM, but you can put up to 256 megabytes on it, which is kind of nice. You have a DRAM chip. And so it's kind of got the same things as this, but like the big deal is you get external RAM. So you get a lot more capabilities. And then it looks like there's a lot of devices that use it. Although, yeah. So like the Linkit Smart uses that chip. The Onion Omega 2 uses it. The Wemo Mini plug. So like a bunch of like Wi-Fi. The home automation switch. So this thing actually that is turning on and off the LEDs, the LED lights for Phil, is the Wemo. It also runs the MT7688. And this one is pretty cheap. You can see you can customize it depending on how much RAM and flash you need. And this one isn't too expensive. So I think these modules were about like $8 or so. And so I was a little sad that this one was a little not feather sized. Oh, can you go to the overhead again? This one's a little bit too wide So that was like the one regret I have about the feathers. I kind of wish I'd made it 1 inch wide instead of 0.9 inch, but there was, I thought at the time, I was like, well, you know, like, whatever, I'll do only a couple things with it. Turns out I want to do more things. But I found a bunch of other samples. So one is this Medora, which I think was like an Indiegogo. So this is another chip, and this one doesn't have a can on it, so it's a little easier to see. So this is the Medora, and it's called the Medora bit. The only thing that's a little annoying about this is they put these capacitors on the bottom, so I guess you have to like drill a hole in your board, like a really big hole, to have these capacitors come through, which is a little bit weird. But this is the Medora module, and yeah, this is the MediaTek 7688K, and then there's this WinBond, you know, this is an 8-pin SPI flash chip, and then there's the RAM over here, and this actually will fit, like just kind of barely, but it does fit. So, you know, you can make a feather out of this, and have the headers, you know, it's basically just making sure that the headers will fit on the other sides. So you can do that. And it's a little big, but so the feather would probably stick out a bunch. But, yeah, it has, like, almost all the peripherals you want. The thing is, I just didn't like that it had these bumpy capacitors on the bottom. I get it. I mean, it's, you know, you can put really big capacitors and you have some space. And you just drill a hole, but that's a little bit weird. So I'm not super into that design. And then, oh, of course, you know, the little ones, the 2 megabyte RAM ones, you know, sorry, 8 megabyte RAM, you know, they'll fit quite nicely. They have plenty of space. But I wanted to maybe make sure that I had an option that was like a higher grade Linux machine, WRT. Okay, so there's the Medora. So I looked at that. And then there's also like I got a Medora module. So this is, hold on, I'll open up this. It's just kind of an all-in-one. So this is kind of like the big version of what like the feather would be. So it's neat is, you know, you get USB, and then there's a USB serial converter, RAM, flash, and then the MediaTek chip here. And then this also has the Ethernet plug, some really cute little right angle buttons, and the antenna. So this is kind of all-in-one. And it also has the host USB, which is kind of cool. So you can, what's nice about these is that, you know, if you have the full Linux kernel, you can compile in whatever drivers you want. So you can have like, this can connect to like, of course, keyboards and mouse, but also like USB webcams, or like, you know, sensor boards, or like other devices, or FTDI, you know, cables, and they connect to other devices and sensors. So having a USB host is kind of cool. Of course, you can connect this to a hub, and like the Linux kernel has hub support, so then you can add, you know, flash drives and you know, whatever you could possibly want via USB. So that is kind of handy. This is a nice little board. It says open source hardware, but I also couldn't find the files for this. But they have a logo, kind of nice. Oh, and then SD cards. That's actually kind of a nice thing about these MediaTek boards is even though the onboard flash is not that big, maybe it's only like, you know, 16 megabytes. Maybe whatever, you can put in a SD card socket, and then if you want, you plug that in, and then you get as much storage as you want. You can, you know, play music through the I2S interface here. It has audio out or audio in. So you can do quite a bit, and I think that it could be interesting to have, you know, a full Linux like capability. Like, even though microcontrollers are very useful, there's sometimes I think maybe you're like, okay, I really want to run Python, or I really want to have like Linux, you know, the full kernel support, full stack support. You know, you want to run JavaScript or something. This is the third module I got. So this is the Eval EM7688, and this one is actually kind of, you know, it was like too cold, too hot, just right. So this one fits in between the headers, so I can turn it into a feather. And there's even a little bit of slop, which is kind of nice. It's quite skinny compared to the other ones, which are a little more squarish. So I can have, you know, the pads and clearance, so I won't run into these headers. And then, of course, I'll just via underneath, and then, you know, this, I'll just make sure to, you know, not bump into any of these vias over here. And yeah, this one is, it's got the WinBond RAM, the MediaTek 7688A, and then, let's see, how big is this flash? It's a 25Q128, which is 16 megabytes of flash. So it's got 16 megabytes of flash, and I think 64 megabytes of RAM. So, I mean, you can actually kind of run Linux. I mean, that's like my first, like, NetBSD computer was, like, not that much bigger than that. A lot more RAM. And then antenna over here, crystal, all that stuff. So I think this one's kind of the winner. I'm kind of digging this one.
AT winner? Oh, wait, sorry. Wrong show.
Yeah. Different. Not the all winner, but the MediaTek winner. So I kind of like it. You know, there's, you know, Linkit has a Linux distribution. What I think would be interesting here is, you know, you have this here. It's going to be kind of long as a feather goes, but, you know, you'll have SPI I2C, I2S. You'll have battery. So, I mean, if you want to make a battery-powered Linux computer, this could kind of be your way of doing it. You get a big battery. And then instead of USB to serial only, because I could do that, and then one of the things that I really kind of, like, tweaks me out about a lot of the, like, single-board Linux computers is they don't have a built-in UART. Like, you can, like, the Onion Omega, it's very adorable, but, like, you have to plug into another board to get, like, debug, and I really like being able to plug in the board into debug. So, like, even the Raspberry Pi, it doesn't have UART built in. Which I get, it's like it's cost cutting because you have to add more expense, but, like, it's really nice to be able to just, like, putty or in. I mean, you know, having to, like, have it come as an AP and then you set the, you know, address and the path. I always find that very annoying. So being able to just, like, log in and then say, okay, set the SSID and password, or set all your SSIDs that you want to have accessed. So having a USB to serial converter here, but instead of using the CP2102, one of the things that Scott and I chatted about was maybe using an ATSAMD 21E, like a small Atmel SAMD chip. And not only will we do USB to serial conversion, right, which is, like, lovely, and, you know, that's a default code that's very easy to do. Just, you don't even need to do flow control. You just have to do, like, baud rate selection and just open up the serial port. The other thing it would do is maybe it would help do the analog digital conversion, because one thing that's a little sad about these chips is they don't have analog pins. But the chip could act as a USB serial converter and also show up as an I2C slave. And then you could basically make it act like a 6-pin analog digital converter. So it would do dual duty and it wouldn't take up a bunch of space. And you'd get, like, the, you know, whatever, 12-bit or 10-bit, yeah, 12-bit analog digital converter that you get in all Atmel chips, basically for free, and it would cost the same as the CP2104. You just have to write the code for it. But then you could, like, you know, very easily use this for almost everything, especially if you have the analog inputs. I think that would be pretty sweet. So, yeah, that's kind of my thing. I only got one more thing, so I'm kind of looking at this one as the winner for this. This would be kind of sticking out here, and there'd be some support circuitry over here, but probably a bunch more capacitors, because there's a bunch of 0201s in here, but I think it needs some more caps, so I would add some more big caps for a nice smooth power supply. And this one, because I kind of looked at the measurements and I thought this one was the most likely winner, I also picked up, like, an Eval board. So I haven't really looked at it. I just kind of plugged it in to make sure it didn't catch on fire. But this is a Eval board for that module, and it was, like, pretty cheap. It's like $50 or something. So it's got the module in here, preloaded with OpenWRT, some buttons. It's got this, like, LoRa module. It's got Ethernet. It's got the SD card slot, the USB host. It's got this, like, ginormous USB serial converter chip, and all the crystal. This is, like, all the USB serial converter chip.
Oh.
And then on-off switch, and then I2S analog out and in.
So I was chatting in the chat room about
what's up?
What we can do together to keep electronics open source, free, shareable, help others. AT Makers is in the chat room, and one of the things I say in every show, we're able, and they're able, to help people in ways we never expected, because the code is shareable, it's open source, you can build upon the boards, you can do all sorts of things. That's the problem with some of the Arduino.org stuff now, so, because they just won't tell us, and there's not any files. So he wants to know if there were analog I/O on these boards.
There aren't, and that's why I would probably have that ATSAM chip as, like, because, you know, you can get a really simple one, like, without a lot of flash, a lot of RAM, for, like, maybe $1. So it would be a teeny bit more expensive than just a plain USB to serial converter, but it would also do the analog conversion, because one of the things that I thought about with, because, you know, I'm, like, you know, playing with CircuitPython and thinking about, like, programmability. So, like, adding an AVR that's controlling a Linux computer is kind of weird. Like, I kind of get it, but I also kind of don't. Like, it's a Linux computer. You should just, like, I mean, yeah, if you really need, like, a robotics thing, but I think it'd be better just to have, like, a full Linux computer that you log in. You run your code on Linux, and then you have, like, a chip that's a helper that just does, like, analog inputs or analog outputs, or, like, if you really need a PWM, it could do those for you, too. Like, the things that you need a microcontroller for, I think, are easier to push off to a micro than Linux computer things push off to a Linux computer. You know what I mean? Because I feel like the programming environment for Linux is so much more powerful. Like, one of the things that I thought would be neat about this is, if you could, instead of actually having to log in, like, once you set it up, it would show up as like a shareable folder with your files in it. And so you wouldn't even have to edit your files on here. You would edit on the module. If you, like, plugged in the Feather, you set up for Wi-Fi, and you got that configured, you would then share the files and then edit them on your computer and save them, and then just run them, like, via your computer, like, kind of like basically VPN into it, just using, like, the Wi-Fi, because it's like, if you're running Linux, it's, like, super easy to set that up, and, like, hopefully you have enough, like, flash and RAM to run that, and I think you do. I think 120 megs of RAM, you can kind of, like, do file sharing. I think
okay, so Python on the Linux board could call out system call libraries to pull the data from the SAMD.
Yeah, it would just be I2C. And you would just, like, I would just basically have a little library, and say, if you want to have analog readings, do it over I2C, and then you would get the reading from the little helper chip. Or if you wanted to have an analog output, you do the same. Just for, like,
that's what we're working on.
The sensors and, like, the things that are picky. I mean, on the other hand, it is a 580 megahertz processor. Like, it's fairly fast. You can do, like, a bunch of stuff with it. Like, it's got, like, this DHT sensor, so, you know.
So that's what we're thinking is, like, even if we were to do, like, an identical open source replacement for the Yun, maybe we wouldn't manufacture it. We'd put out the reference design, but we'd make, like, a Feather with this or something.
Yeah, it kind of inspired me to think, like, oh, you know, like, these modules are low cost and cheap enough. If I can make a Feather that's, like, you know, $30 or $40 with all this circuitry fully assembled, but you can have, like, a little Linux computer, I think that could be kind of neat to do. I mean, like, the thing about the MediaTek chip is it's really cheap. Like, I think the bill of materials for that module, just the raw module, I think the bill of materials is, like, maybe $5 or $6, which is why you end up with, like, all these Kickstarters and Indiegogo. So, like, the Vocore uses this chip, the Onion Omega uses this chip, and there's, like, two other, the Medora uses this chip. There's, like, a bunch of these, like, Linux computer breakout things that use this chip, and when they do the crowdfunding, they always make it be, like, $5, because they're like, well, that's the bill of materials, the bill of materials cost. But then it never really scales, because it's just, like, it's really hard to get distribution when the cost of your thing is the cost of your thing. And you're, like, starting out.
Yeah, and then ATmaker says this was actually put things into an area where I could help out with the code, Linux tuning. Yeah, this is the other thing. Raspberry Pi got a lot of people involved because there was a lot of expertise. This might be a way to bring in that large community as well.
Yeah, I think, like, look, it's not going to be Raspberry Pi. It's not nearly as fast. It's not going to be as, you know, intense.
But different strokes, different.
But it's a WRAT, which is well known. It's not, and I'm saying it's not going to be a competition. It's a different thing. I want it to be, like, a low power, very small, like, Feather compatible, and because MediaTek releases files, it's actually, we can, like, make as much of it open source as possible. And then, because WRAT has, like, a community and lead, which is I guess is another distribution, there's people who have already done a lot of hacking and modding with these Wi-Fi routers. I think it would be kind of neat to just see, like, well, let's see if we can make a small Linux computer that can work with, like, the Feather ecosystem, and then, like, work with the microcontroller as the microcontroller is helping rather than the microcontroller controlling. Yeah. So anyways, I just got these samples today.
Okay, red.
So this is all very futuristic, but I always wanted to kind of design a little Linux board. So I'll probably use this, and then I'll try to design the actual module itself too. I'd like to get the practice. It doesn't, I mean, I don't say it's like, oh, how hard can it be, but it's like, it's a one-sided board, 8 layers, looks like, with 3 chips and a couple of passives. So I think I have a shot of being able to design my own. I always wanted to sort of design my own Linux computer. I thought that'd be fun.
Are you going to have the SAMD M0 as a serial input controller and the module as a Linux server? Is that how it works?
Yeah, the SAMD would only be an I2C slave, And what it would do is it would get I2C commands, because the I2C pins are like predefined on this module. So it would just, I just use whatever address is going to be used by any other sensor, and it would just basically act not only as a USB to serial converter, but it would also do the analog digital conversion for you. So you'd get ADCs, and then, like it's not hard, so you could upgrade it, the firmware. I could add like analog output for the one pin that does that. You could add like I2C commands that will let you do PWM out for like the, because you don't usually need all 6 analog pins. So you'd have 6 pins that could be analog inputs, they could be PWM outputs, they can be, NeoPixel output pins. So like I could have like a list of I2C commands that this Linux computer would be able to send for just helping it with the things that are annoying for Linux computers to do, which is like analog, NeoPixels, PWMs, and servos. Right? Those are the things that it like. Linux can't do those. It can do like OAuth, which is like really annoying to do on an Arduino compatible. It can like buffer huge files. It's got a SD card file system. It can do it can decode MP3s, on software on the fly super easily. It can record audio. It can you can connect a webcam to it. All that stuff is like super Linux is like top notch, but it can't twiddle a pin at 50 nanoseconds. It just can't do it. It just freaks out. It just can't get that timing right. So that's what the helper chip would do. And it would also do USB to serial conversion in the background, because that's super easy.
Okay.
So that's Sample Monday.
Sample Monday.
Thank you.
All right. Thanks for everyone in the chat room. I was giving them some background about what we're trying to do with the opensource.org folks, because the new Arduino.org uses the term open source in a way that's never been used before, as in it's not open source. So they might help us out, and then we're just going to keep making open source hardware and software, and we'll make sure our libraries work with CircuitPython, and we'll just have the menagerie of hardware. Yeah,
I mean, for all the libraries that were written in Python, it would just work with this. You can install mini Python on this, and you'd be just running Python.
Yeah.
Which is silly, but you can do it. And if other people have info on, I just started looking into this. So if anybody's oh, the best distro for this chip is this blah blah blah, send it over and I'll take a look, because I'm kind of
whatever distros you think that would really work well, and you know what you're
what you're
talking about. You can just email PT at Adafruit.
Yeah, I think LEED seems to be the one that people are using.
What is it?
LEDE.
Lead.
Yeah, that seems to be the one. But if anyone has ideas, I mean, this is supported in OpenWRT, and LEED, so I guess I'll probably start there. But I've never done my own distro from scratch. I mean, obviously this is going to be it's a very minimal Linux. It has to run within.
Yeah, I think it'd be cool. I
megabytes.
think it'd be cool. This is one of the neat things about innovation and technology and open source is, you think there's a roadblock or a barrier. At most, it's a speed bump.
Yeah.
And for us, it's a ramp to launch ourselves into a new wonderful place.
Yeah. I also like these little modules. I mean, this is ridiculous. I mean, even though it's only 2 megabytes of flash, 8 megabytes of RAM, I mean, the fact that this is a little Linux computer is just is awesome, right? I mean, you can absolutely put this in an SD card.
Okay, we'll take a couple questions. We'll hang out.
Yeah, sure.
Yeah. So, anyways, we put the Metro as an open source, an OSHWA certified thing, just to show, hey, look how easy it was. And then we have a CERN, open hardware CERN license for one of our Pi projects. So I think what we'll do is, when we're specifically showing, hey, here's an open source alternative to something that says it's open source but it's not, we'll just get it OSHWA certified, because it's super easy. It took 30 seconds. Just here's the files, here's the license.
Cool.
Yeah, all right, I'll wait for this question to come in. Yeah. The little button thing worked.
Yeah?
Yeah, it worked fine. So then goes this, and then it's whoop, there you are.
Do you want me to show what it is that we made?
No.
Okay.
I don't want to unplug it while I'm live.
Yeah. It's a little Python acting thing.
Yeah, it's time to switch to CircuitPython.
It is. Hi. Bye. So you're going to set that up. We'll get you one for the
Okay.
Ask Engineer Desk too.
Powering a string of dot stars that are being controlled by an Arduino, can I power them both by the same 5-volt power supply?
You can, just make sure it's a good one.
Okay. And have you ever played around with RT Linux?
I haven't. I haven't tried RT Linux,
Okay.
so I don't know.
Can you expose the data via the /proc file system in Linux?
Yeah, there's a bunch of stuff you can do with file system. You can always write a driver that exposes stuff. So, you know, ideally, if I was doing a good job, I would actually hide all the analog stuff behind the scenes and have a kernel driver that would do it. But because it's such a
SAMD data, Bill said every code platform could read them.
Yeah.
Together.
I know, but it's like I2C is also kind of universally understood. So
okay.
I'd more rather have it just be I2C and then, you know, the Python can do it or C can do it, or then just write a little helper program in C to do it. That, you know, you just type in like read analog 0 and it will like just return a floating point.
And then Jordan says the MediaTek chips support USB device mode. Not all of them though, right?
This one doesn't seem to.
Yeah.
Which is a little. It's the one downer. I kind of would have liked that because it would be cool if you could plug it into USB and it would show up as you know, a USB serial device, like a gadget. That's like the one thing that I was like, well, that would have been really cool, but it didn't.
Have you seen the VoCore 2 board?
The VoCore 2 is the same chip.
Okay.
It's just double-sided, which I'm not into because it's like I can't pick and place it.
And then any thoughts on a new cellular Feather M0 and A1A base? Yeah, sure. I mean, these modules are huge. And
there's no finished design for it. It's not a top priority because not a lot of people use a cellular Feather. But they might if I had a better design. But it's just something I'm taking a break from.
Would battery management be the same as the other Feathers?
I've thought about that. I actually think what I would do is have, you know, one of the analog inputs on that device would be the SAMD, and you'd have to request the battery measurement, and so, or like, you know, the VDD, basically the measurement. And so that's one of the things that would be useful about having analog inputs is that you would be able to tell when your battery level is going low and you could shut down. But it's not, again, because I think the flash file system is decompressed into RAM. You don't have like as much issue if you just shut off in the middle. I mean, these routers, you can unplug them pretty much whenever you want.
Someone's asking about we have the FlashForge Creator Pro. We also have MakerBot.
Yeah.
To Office. Okay. All right, that's it. Well, thanks everybody.
Yay.
We'll see everybody this week. We have a special show on.
We have so many shows.
Wednesday at 7, Show and Tell Race Car, and then we have 7:30 Show and Tell. Then we have 8 p.m. Ask an Engineer, and I hooked up a bunch of stuff, so I'm back on the Desk of Lady Ada streaming. We just had so much stuff to do. It's
also was really nice out, but yeah, I've been doing all sorts of really cool stuff with. I got some interpolation going on here that I'm doing, thermal camera stuff. We're training up a new person in our embedded group, so we're going to have a lot more hardware soon. The Gemma M0 PCBs are going to be in shortly.
Yep.
And the Trinket M0s after that, and so there's going to be a lot of hardware. We just took a couple weeks off to take care of biz.
Okay. Thanks, everybody.
But we're here. We're here for the next 10 years.
Okay, bye.
Later.